So question number 37 says, in the movie Close Encounters of the Third Kind, there was a scene in which the star Richard Dreyfuss was approaching Devil's Tower in Wyoming. He could have determined his distance from Devil's Tower by first stopping at point P. We'll draw that right here. So he's approaching Devil's Tower. He stops at point P right here. And estimated the angle of P as shown in the figure. So he's estimating that this angle right here is 13.5. 13.5. He then moves 100 meters closer, so we'll make that 100 meters, and he's now at point N. We'll use a different color. So he's now at point N, and he measures the angle to the top, and he records that it is 14.8. 14.8 degrees. So it wants to know this distance. We'll call it lowercase n. So the first thing I did was I thought, what angles do I need to know? And I knew I wanted to know that angle. So I just did 180, because this is 180 degrees, minus that 14.8. And that gave me 165.2. So I know that this angle right here is 165.2. Now, because we know that the three angles of a triangle add up to 180, we can calculate this angle right here. And all we're going to do is take 180, subtract 13.5, and then subtract 165.2. So we'll go 180, subtract 13.5, and 165.2. And that leaves us with 1.3. So we know that this angle is going to be 1.3. So now that we calculated the three angles in this first triangle, I redrew it so that it'd be a little bit easier to read. Next thing we can do is we can calculate this length. We'll make it x. What we're going to do is we're going to write the sine of 1.3 over this length, 100. Its opposite length from the angle is equal to the sine of 13.5 over its opposite length, x. Now all we do is multiply that side by x and that side by 100. We get the sine of 1.3 times x is equal to the sine of 13.5 times 100. Now we can just divide both sides by sine of 1.3. We get x is equal to the sine of 13.5 times 100 all over the sine of 1.3. And when we put that into the calculator, we get 1029. So x is equal to 1029. And now we can write that into this triangle. So now that we calculated this length, what we're going to do is just solve for this angle right here. And we just take 180 minus 90 minus 14.8, and that would give us 75.2. Now that we have that angle, we can do the same trick that we used with this triangle to solve for n. So we're going to take the sine of 90, which is just 1, and put it over this length, 1029, is equal to the sine of 75.2 over this length, n. Now we multiply the n across, multiply the 1029 up here, and we get the sine of 90, which is just 1, times n is equal to the sine of 75.2 times 1029. And this is just 1, so we can just multiply it in right there, and we get n is equal to the sine 75.2 times 1029. And so our length n comes out to be 995. And that's your final answer.